So what I wanted to do is primarily look at some of these problems that are made up of expressions, and so you have to figure out how to set up an equation and solve for your missing value. But not just those. There's one in particular I wanted to look at. If there's another problem that you struggle with, weren't able to get the answer, or you did get it and you just want to kind of walk through it and make sure you did it right, whatever the case, you can let me know there are specific problems that you have questions about, and we'll look at those as well. So we're just going to start with number one because there's an expression there. One of the things I was really trying to emphasize, and repeatedly said this, is if you can memorize the 5 properties of the parallelogram, those are the most important ones to memorize because they're going to apply to every quadrilateral. So you can just keep using those properties. So one thing we know about parallelograms is that opposite sides are congruent. So this is what you can do the first thing with every problem, is you can just mark opposite sides as congruent. You know opposite angles are congruent. That might or might not help you, but you know opposite angles are congruent. So you can mark those as congruent. You know the diagonals bisect each other. If there are diagonals here, I would kind of mark that. And we'll see one of those later. But you can mark some of these properties already. The opposite sides are parallel. So I can mark these as parallel, which in this case doesn't matter a whole lot. We're not going to use that one. But anyways, you don't have to mark them up completely, but I am saying that if you know these things about a parallelogram, then it's going to be true for all parallelograms. And that includes a rectangle, rhombus, and square. So let's just start this one. We know, and the key thing here is that opposite sides are congruent. So the 4x minus 4 and the x plus 5, I know have to equal each other. So that's what I'm going to do. I'm going to go ahead and set an equation, 4x minus 4 equals x plus 5. And from here, it's just basic algebra. That was the hard part of this. Solving the algebra, if I subtract x from both sides, you get 3x minus 4 equals 5. Add 4 to both sides, 3x equals 9. Divide by 3, x equals 3. There's no units on this one, though if there were units, I'd want you to write that down. Okay, now the perimeter, and not too complicated, but you can work a little bit fast on this. Remember, perimeter is the length all the way around the quadrilateral. So we need to take that x and plug it right back in. You can plug it into both sides if you want, but remember, opposite sides are congruent, so it should be the same no matter which one. So if I plug 3 in right here and get 3 plus 5, not 3 times, 3 plus 5, then this side length is 8. We can double check it on the other side. I can just do 4 times 3 minus 4, and that's also going to be 8. And so that's good. They should be the same. But anyways, we just add that up. We know this is going to be 4 on the right side. So 4 plus 8 plus 4 plus 8 will give me 24. Okay. So again, hopefully just seeing it, you're like, okay, this isn't too bad. Pretty straightforward, pretty easy. Especially just keeping those 5 properties in mind. Most things are going to come back to that, to one of those 5. But every once in a while, you might end up using one of the other properties. Josh, make sure you're paying attention up here. Okay. Rhombus for number 2. This is one I got a lot of questions on. There's no expressions here. So at first glance, it appears to be kind of simple. And after you understand the properties, hopefully it's simple for you as well. But I did get a lot of questions on it, so I wanted to talk about it. So you will have the reference for the properties. You need to know how to look back and kind of interpret and figure out what's going to be useful. You had the properties yesterday. You could have looked at them, and yet even today in first hour when I was going over this, a lot of people were just kind of clueless on what the properties of a rhombus are. You don't have to have them memorized, just look them up. So is there any property in particular for a rhombus that's going to help us? Yeah. There it is. The diagonals are angle bisectors. We only have one diagonal on there, so we don't care about the other one. But we do know that this diagonal is running right through the middle of these angles. So that means these 2 angles are going to be congruent. And these 2 angles are going to be congruent. Not only that, they're all congruent to each other. That doesn't matter in this case. But it turns out they're all congruent to each other, the 4 that I marked, because opposite angles are congruent. So if this is an angle bisector, what is the value of x going to be?
32.
32.
I mean, I thought you were talking about pi.
Okay. So that is a really simple problem as long as you know the properties. But the reason I was getting questions is because people weren't reading the properties and figuring out what to do here. So we know the larger angle, if x is 32, that means this large angle right here is going to be 64. So what does that mean for y? How can I solve for y? Let me ask. 180 minus 64. So one thing to keep in mind, this is one of your parallelogram properties. All consecutive angles are supplementary. So 64 plus y will equal 180, and you can solve for y. Okay, yeah, there it is. It's 116. So a lot of people did not ask me any questions on this one because it is, if you look up the properties, it's not a difficult problem. But a lot of people didn't because they weren't able to understand or just didn't look up the rhombus properties. You're going to have to do this, take this on your own. You're going to have to take that initiative on your own tomorrow. Okay. So I was going to jump down. We can look at number 5. Now again, if there are other problems on this page that you just want to go through to make sure on, let me know. But I was going to jump down to number 5. We're solving for x, and then we're solving for IG. Okay, and we're obviously looking at some diagonals in this case. What do we know about the diagonals of a rectangle? They bisect each other. That's going to be important. What else? And the diagonals are congruent. Those are the only two properties we have for diagonals. We're going to use both of them. But let's start with the one that the diagonals bisect each other. Because we can already see we have the x plus 12 and the 2x are each a different half. But because these diagonals bisect each other, we know that x plus 12 is going to equal 2x. So to solve for x, great. I don't want conversations to keep happening. All right, so to figure this out, all we have to do is subtract x from both sides. So x equals 12. This is a really basic equation, easy to solve. So we got x equals 12. But now we're solving for IG. And we don't have any information given on IG, but now we're going to think about that other property. What is the other property with diagonals? There you go. In rectangles, they're congruent. So that means if I know the length of FH, then I can solve for the length of IG. It's going to be the exact same. I don't need to solve at that point. So let's figure out the length of FH. We have to take our x, plug it back in. I get 12 plus 12 and 2 times 12. Just to make sure we did it right. We get 24 and 24, 48. Yeah, again, I didn't put any units on this, but if you want to be in the habit of writing, I'll probably have that on the test. But if you do see units, pretend it says centimeters there. Make sure you write that down. Or x isn't technically in centimeters, but that's okay if you write it. Okay. I think the only other one I wanted to look at on the front side was number 10. And this one, we've got a parallelogram again. That's another thing. I forgot to mention that at the beginning. Make sure you are looking at what kind of parallelogram you're looking at. In this case, it's just a regular parallelogram. There's 5 properties to keep in mind. But if it was a rhombus, then you'd know to consider some other properties. Okay, so a parallelogram right here. And which property is going to help us in this case? Diagonals bisect. So that one keeps coming up. Hopefully it's getting just more and more ingrained in your memory so that you'll know what to look for. So these two, now parallelograms, the diagonals are not congruent. So we can't say that all 4 of these diagonal halves are the same, but each pair of diagonal halves are going to be congruent. All right, let's just worry about 6 and y. What is y going to be? 6. Yeah, really simple there. So the length from B to D is going to be 12. And this is the other thing I wanted to mention. make sure you're looking at what the blank is asking for. It's not there is an x and y, but it's not asking for x and y. It's asking for the actual total length. So as long as you just take a second to look at that, you shouldn't get tripped up on it. But anyways, AC, we're looking for the length there. This is one where we have to do the same sort of thing. Luckily, when we're setting up equations, it's just like we've done before. So nothing new as far as what the equations look like. We're either setting them equal to each other or setting two things as adding up to 180. So these two will be equal because those diagonal halves are congruent. 3x minus 5 will equal 15 minus x. Doing the really basic algebra, add x to both sides, you get 4x minus 5 equals 15. Add 5 to both sides, you get 4x equals 20. Divide by 4, x equals 5. And here's where the temptation is going to be just to write 5 down and move on. So if you did that, you got x correctly, but that's not the answer we're looking for. Plug that back in. What is each half going to be? 10. So yeah. So the total length is 20. There's your answer. All right. Were there any other problems on the front of this page that you guys wanted to look through? And you can keep looking because we're going to look at the back side. And if there are other problems that you're looking at and you decide we want to come back to them, we can do that before class is over. Okay, so the back side of this, it's a little bit small up on the screen, but all 4 of these graphs are here. I was only going to go through 2 of them. And remember the process for determining if lines are perpendicular. Find the slope of each line. Multiply those slopes together. If you get -1, they're perpendicular. And that's what I'm going to be looking for. All right, so if we look at the first one up here, it's a little bit hard to see up on the screen, but you can double check me on the on your own paper. But we're going to see what the slope for each one. I'm going to start with this positive slope. One thing to keep in mind, you can tell yourself right from the beginning if this has a positive or a negative slope. Is that positive or negative? That one's positive, so I'm going to even mark this one as having a positive slope. The other one has a negative slope. It's going kind of downhill. You probably learned uphill and downhill considered going up a mountain and down a mountain or something like that when you're learning this stuff. So that means my slopes here should end up either positive or negative. All right, so if I look at the positive slope to start out with, I'm going to go up. And if I add that up, I'm going up, let's see. I'm going up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to write over here, this is plus 12. That's, and you might want to, on a problem like this, you might want to count it a couple times, double check. So that is plus 12. It'll show up in a second. All right, now I'm going to go to the right. Now I want to figure out how far to the right I'm going. There it is. It is plus 13 when you add that up. So we end up with a slope that is 12 over 13. I already knew it was a positive slope because I can just see that on the graph. But now I can see I'm going up 12, right 13. That gives me a positive 12 over 13. That's the exact slope. Okay, the negative slope. I'm going to start this one by going down. Looks like I'm going down 6. So that's minus 6. And then to the right, I'm going to the right 5. So that's a positive 5. All right, so the other slope I end up with is negative 6 over positive 5. In order to make sure that these are perpendicular or not, I'm going to multiply those together. 12 over 13 times negative 6 over 5 equals, well, 12 times negative 6 is going to be negative 72. And 13 times 5 is 65. So we can see it doesn't matter what the number is, except that it's not negative 1. Does that make sense?
Yeah.
Okay. So now we've got, no, these are not perpendicular. And it'll be pretty clear on the test, are these perpendicular, yes or no? Okay. So we'll just do one more of these. And we'll just go to the right. Look at the one at the top right of the page. Same sort of thing. I'm going to start with the positive slope here. So I'm going up 6, right 5, and I'll write that down. So that's plus 5. That's plus 6. And you can double check the counting on that. So slope here of 6 over 5. For the negative slope, I'm going to start with my rise and run, and I like to go left to right. So starting at that same point that I ended at, I'm going to go down 5. So that's minus 5. And then right 6. So that's plus 6. All right, any questions on the slope there? I did that kind of quickly, but I'm assuming after a few years you guys can find slope. So it's negative 5 over 6 here. Now, just looking at the slopes, you can probably tell that these are perpendicular. But I want to see you go ahead and do the multiplication. So 6 over 5 times negative 5 over 6 gives me negative 30 over negative 30. Oh, sorry, over 30. And there it is. That will simplify down to our negative 1. So yes, these are perpendicular. Okay. So that's really what you can expect on the test. With the ones we went through, you shouldn't see anything more challenging than stuff like that. Though at this point, I want to ask, are there any other questions on the front or on this back side that you guys wanted to go through? Okay. So if you do have individual questions, you still have a few minutes in class. So please ask if there is one you wanted to go through. Otherwise, I want you guys to look at this or the other handout from Monday and just get some extra practice in if you did not finish it yesterday. And there you go.